Hello Internet, my name is Quinn and this is Blondihacks. I'm working on my locomotive this week and I'm going to make the boiler saddle, which is a structure that holds up the front end of the boiler and also supplies insulation for the steam manifold to keep everything hot down where the cylinders are. So let's go. The boiler saddle sits under here and it kind of wraps around the underside of the smoke box and holds everything in place just above the steam manifold here. It actually wraps around the steam manifold and helps insulate it. You'll see how this all works as we go along. If you've been watching this series, you know that I've had these washers in here as spacers because I was under the impression that this little gap in here was going to be filled by the saddle, and those spacers are needed to keep the boiler level temporarily while I worked on other things. Once I got looking at the drawings, though, things got confusing. So you can see how the saddle wraps around the steam manifold. However, it doesn't seem to be attached to it like I thought it might be. It just kind of encloses it. And looking from the other drawing, you can see there's no screws or anything going into the frame or the manifold from this saddle. The saddle is screwed to the smoke box, but in the front it doesn't appear to be attached to anything. So that perplexed me for a little while, so I went back and started looking at some of the other drawings. One of the challenges with this book is that there are sub-assembly diagrams, and of course there's drawings for every part, but there aren't a lot of inter-assembly diagrams. So sometimes you put together the entire smoke box assembly, let's say, but it's not clear how all the pieces of that assembly relate to the boiler and the chassis and the things around it. So it took me quite a while of flipping around to sort of figure out how this all goes together. And to make things even more interesting, it looks like there was a design change here because the saddle pictures show these bolt holes. All of Kozo's photographs of his own component show these bolt holes. Those bolt holes are not in the drawings. So I think maybe he was thinking originally he would bolt this to the manifold and changed his mind on that for whatever reason. And like I said, those aren't in the drawings. What I decided eventually is that what's supposed to happen is the saddle just keeps the boiler from lifting up by retaining it under the manifold, but the front of the boiler is actually clamped down to the top of the steam manifold by the plumbing fittings. So what that means is I need to get my boiler level some other way because I thought the saddle was going to do that. So I figured out where level is with some shims, and I went ahead and machined a little spacer that's going to sit on top of the steam tee. So there's clearly some sort of dimensional error. My boiler is sitting a little high or it's a little too tall or something, and so this little spacer is necessary to get it level. Now if I get the boiler on there, you can kind of see how it's going to sit firmly on that, and then the plumbing fittings inside the smoke box are going to clamp it down to that, and that's really what's retaining the front of the boiler. The saddle is really just an insulation box, I guess, around the manifold. But let's get going on that. I'm going to start with the saddle component itself, the curved part at the top, which is the trickiest. I made an oversized estimate of how big this piece needs to be, because of course we're going to bend it. I squared it up on the shaper, because shaper. Kidding aside, the shaper is actually perfect for this kind of cut because most of the force is along the part. There's no lateral forces or lifting forces the way that a right-hand helix end mill has. So cleaning up the edges of sheet metal is a great thing for the shaper. Then I annealed this piece because it is going to get bent and it'll be a lot easier if it's nice and mushy. I do this in the dark so it's easy to see the color. Not always, but I usually do it in the dark. Then I'm going to try to make this curve on my slip roll. Regular viewers know I have a bit of a love-hate relationship with this thing. Well, a love-disappointment, I guess, relationship. Sometimes it works great and it's the perfect tool and I love it, and puppies and kittens for everybody. And sometimes I just cannot get it to do the thing that I want. And I think that's mostly down to operator skill. But this time, I'm happy to say it was a puppies and kittens situation. Everything went really well. That produced a very nice curve. I just went a little bit at a time, checking against the smoke box, and ended up with a very nice fit. Over here on the side, you can see it's an excellent fit. It's not as good down on the bottom where it's going to be sitting because, of course, that's where the solder joint is, and it's not a perfect cylinder down there. The solder joint is a little bit of a flat spot, but that's okay. Still an excellent fit. Moving on, I'm going to do the front and rear plate pieces next. The interesting thing about this assembly is that I know at this point there's a lot of dimensions on the boiler and possibly the steam tee and possibly other things that aren't quite right as we start to bring together all these big sub-assemblies that were all built often years apart and with very different methods. Sheet metal work in the case of the boiler and machine work and handwork and some of the other surrounding assemblies. I'm finding all of the, accumulated errors, and I'm having to do more measuring directly off of my locomotive and using the drawings more as a starting point. So that's why I'm going to make these panels first, and I'm going to do a bit of a convoluted order of operations because I have to do things in a certain order that will allow me to take measurements from my model as I go along. Otherwise, this is not going to fit at the end. So I'm making these front and rear plates first, and the idea is I'm going to leave them overly long, but I can make them a perfect fit left to right because that's not going to change. The frame rails are what they are. So these pieces have been machined to a perfect fit in here. They're not going to be that close to the manifold. I'm just mocking things up here. And now I'm going to cut the curve at the top where the saddle is going to sit, and I'm going to leave the bottoms of them over long because I suspect I have vertical error in where my boiler is sitting. So I'll mark some center lines on these. I also laid out all the intersection points of the curves. All the dimensions except the width on these front and rear plates are oversized, so I can machine them down after. So that's why things will look a little funky here for a while. But with the intersection points, I can lay the saddle in where it needs to go and trace that out. So that's the curve I need to cut. Now I'll double check that I've got enough material below so that I have excess to ensure that I can get down below the bottom of the steam tee, which is what has to happen. There's a bottom plate that goes under the steam tee at the bottom. And no. It turns out, no, I do not. The piece that I started with came up a little short. So I made that one again. Well, made them both again, a little bit taller this time. Well, a lot taller. I wasn't taking any chances the second time, and I gave myself a ton of extra material down there. And now I can cut that curve because I know I'm going to have enough material later to mark and cut down to size for the steam manifold. I'll super glue these together for the next couple of cuts because, of course, these parts are identical. No sense setting them all up twice. Again, I've got reference edges cut all the way around. Even though they're oversized, I put reference edges on them so I can have square and parallel references and give that a chance to set up. I'm going to cut this curve on the faceplate. The setup for this was the same as I did for the smokestack parts, so if you watched that, you know how this was done. I'm not going to go over it again. No, I'm not doing this on the rotary table, and no, I'm not going to explain why, because I've explained that so many times, folks. Lathes are just better, and let's leave it at that, but you do it however you like. This is an easy cut on the lathe, and it was a quick setup, and the result will be excellent. I'm getting close now. My layout line says I need one more cut, but I'll do a quick test fit here and see how this is looking. And survey says, oh yeah, look at that. That is looking very good indeed. I think I'm going to stop there, even though my layout line says I should do one more cut, because I don't want to go too far, of course, and that looks like an excellent fit. So why would I do another cut? But I should have used more light when I was doing that check. Future Quinn here. It turns out I actually had a little gap there because I couldn't see because it was a little too dark around the lathe faceplate there. And so I had to do a little bit of fine-tuning of that fit over on the die filer after I did some checking with better light. So, live and learn when checking test fits. Either trust your layout lines better or use more light. Next, I'll set up to cut the big rectangular hole that goes in the middle of the saddle or near the middle. I'm doing all these operations from centerline references because, of course, all the outer dimensions are still way oversized on everything, and I'm not positive that everything is perfectly symmetrical, so using center lines is just safer. I'll start by putting a drilled hole in one spot on the hole, and what that will allow me to do is plunge straight down with the end mill on each pass as I do little laps around my rectangle. Now, this is a center cutting end mill, and you can, of course, plunge with end mills if they're a center cutting end mill, but I don't like to do it. They're not very good at it, even if they are technically center cutting. It just doesn't work that well. So by cutting a little hole somewhere, you can line yourself up on that hole, and then as you plunge, only the outer parts of the flutes are cutting, just as the end mill is intended to be used, ideally, and it's a lot less drama. So a simple trick, but that allows me to do multiple passes around my little rectangle until I get all the way through. That went very well. Quick test fit, and it looks good, except of course the corners are overly round because of the end mill, so we'll need to square those up, and the die filer will make short work of that. If you're wondering, that rectangular hole has to be cut after the piece is bent because A, it's dimensioned from a plan view projection, so it has to be done afterwards or you don't know what the dimensions actually are supposed to be. And B, if you do them to dimension and then bend it, then it's going to get smaller as you bend it up. This hole is supposed to be a generous clearance around that bulkhead fitting, and indeed it is. Skookum. Incidentally, this clearance fit is when I realized that the saddle does not actually clamp the boiler down the way I thought it did, or rather hold it up the way I thought it did. Before starting this component, I checked the dimensions of all of these different relationships between these elements, and once I realized that that rectangular hole was a big clearance fit around the steam manifold, then I realized that I was misunderstanding how this component actually works, and I was going to have to shim the boiler. Over here on the shaper, I'm making a little packing block that's going to go between those front and rear plates of the saddle. And this is going to be useful for all sorts of operations, as you'll see. I'm going to use this thing like 50 times over the next few minutes, so I'm not even going to show you all the times that I've used it because it's just incredibly useful. So this is machined to be the exact internal dimension of the saddle. And I've also put a little threaded hole in the top, and you'll see where that's going to come in here momentarily. So I'll set this up in the vise with the two front and rear plates, and I'll align them with their machined edges, which are of course valid references. And now I can get the saddle in here, and I've actually scribed a center line on the front plate, which you can't see, but that allows me to line up the saddle and get it centered on the front plate, align all the center lines as it were. Then that threaded hole with some copper shims allows me to clamp down on the whole assembly through the hole. And the reason I want to do this is so that I can have everything all clamped together in final position, and then that allows me to drill and tap some fixturing screws through the entire assembly all at once, and it's going to guarantee alignment of everything. I start with a screw in the center of each of the plates because that's straight down, that's normal to the surface of the curve, so nothing's going to wander. And even though I'm going to end up with an asymmetrical pattern, as you'll see, because I'm only going to do 2 screws in each plate, but having one in the center was the easiest way to do the first one. And it doesn't matter if they're asymmetrical because these are just solder fixturing screws, and they're all going to get filed away in the end, and they will never be seen again. This process is really easy if you can manage to clamp the whole assembly together like this, because all you do is drill tapping drill size through all of the parts, and then you tap through all of the parts. And then you take the clearance drill for the bolt that you're using and you drill out the top part. You drill out the threads that you just made in the top plate, and then that will create a clearance hole with threads underneath, and the screw will then clamp down on it. Those last 2 steps can be reversed as well. Sometimes it's easier to drill the clearance hole first and then tap the lower part of the hole, whichever is easier. But I did that front and back. That gives me 2 fixturing screws, and now it's safe to move the whole assembly, and I'll tilt it over to the side so I can get a square attack, if you will, from the drill on 2 other places on the edge. It doesn't matter where these 4 screws go as long as there's 2 screws in each plate, so they'll stay put. That is looking good. Now, before I solder those, though, I want to do some more cuts, but I need to be able to hold all of this in its final position in order to mark the next 2 cuts. This is where my order of operations gets convoluted because I'm having to adapt to what my locomotive is and not what the drawing says it should be in a few details. So I set it all up now, trying to get the saddle in its final position, but the bolt holes are in the way. However, it's close enough that I can mark where the scalloped side cuts need to go. If you look in the corner there and see the diagram, you'll see the sides have a decorative swoop to them. And so I can make these cuts now before everything gets soldered together, which is necessary. As you'll see, these cuts would be impossible if I tried to do them later. Now, these cuts are going to be pessimistic. They're going to be undersized because the bolt heads were in the way on that test fit with the boiler. So once those bolt heads are filed down after soldering, everything's going to move up a little bit, and that's okay because then I can just deepen these cuts a little bit. But I have to get them started now, and you'll see why in a second here, because I'm going to solder this whole mess together now, and once that saddle is soldered in place, those side scallops would be impossible to cut. There's no way to get the end mill in there. Of course, in a perfect world, you would just make the front and rear plates to the drawings, solder everything together, Bob's your uncle. But as I've established, I have a lot of errors that I'm having to adapt to in my locomotive. I'm going to be soldering this upside down as is necessary, and I'll use the new to me but very old whiteout trick, which I'm a big fan of now. Keeps the solder where you want it on convex curves like this. For this soldering job, I started with a preheat of the front and rear plates because they have a lot more mass than that thin copper saddle area does. So you always want the two sides of the joint to kind of reach silver solder flow temperature roughly the same time. So a little preheat on the more massive thing always helps. And then attack the joint from the far side until that flows. And then push it around with the scratch rod to get a nice looking joint. This is the Kozo Hiraoka soldering method in a nutshell, and I love it. It is the best soldering method I've found by far. I've done a whole video on this method if you want to know more. It was relatively easy to set all of this up at once for both joints, so while things were still kind of preheated, I flipped it around and heated the other joint at the same time and soldered that one as well. Saved me one round of pickling and assembly and fluxing and so on. That took one more trip through the pickle bath, and then the screw heads get filed off with a half-round file. So far so good. It's starting to look pretty saddly. Now I should be able to do some real test fitting now on the boiler because those screw heads are out of the way and everything is soldered in its final positions. So let's go ahead and do that and see how much trouble I'm actually in. The saddle slides down over there nicely. You can see it's got a nice clearance around the steam tee. My little shim is in place, so that'll sit roughly there. Let's get the boiler down there and see how it fits. It should fit perfectly because that curve, as I determined earlier on the bench, was perfect. However, it does not quite, as you can see. The fit is not very good. It's not much better on my side. That gap you see on your side is just as bad. So yeah, that was not great. I took it over to the bench and double checked, and sure enough, it fits perfectly over on the bench. So what's going on here? There must be some kind of over constraint being created with the frame rails because that's what's different from the bench to the real model. Took a little fiddling to figure out what the problem was. I'll set it up on the surface plate so you can see. With the boiler sitting square on the surface plate, you can see that the saddle is not sitting square. The bottoms of the feet are crooked. So the whole saddle needs to kind of swing to the side a little bit in order to be straight. Luckily, this is actually quite an easy fix. I just need to remove a little bit of material here to give clearance on one side around that bulkhead fitting so that the saddle can swing over a little bit. I went a little bit at a time hand filing that side of the opening, and it turns out I didn't have to remove much at all. It was, I don't know, it was a few thousandths or something. The length of the legs was exaggerating the error, so it really wasn't much. And now, as you can see, that sits on there much, much better. Now it's not perfect, but more on this in a minute. But for now, I was happy enough with that I could proceed, and I can now proceed to get those side scallop cuts to their final depth. So I measure with a feeler gauge how much they're now sticking up above the frame rail, and I cut them down to be flush with the frame rail plus extra for the thickness of the side skins that are going to go on there because the side skins are supposed to be flush with the frame rail. So I cut some little pieces for that, annealed those, and I used this little bending tool that I made way back at the beginning of this project to kind of get those bends started. Once they're kind of close, then I can mock them up on the piece, and I'll use a piece of round bar as a hammer former to punch those down tight into the corners. This brass is quite thin and it's been annealed, so it doesn't take a lot of force to just kind of mush it into the corners. I was pleased with the fit I got there, so I did the same thing with the same methods on the other side. Those are both still over length, of course. And now I can take those over to the mill, again clamp everything in its final position on the entire assembly, and drill and tap everything all in situ. Very, very easy if you can do it that way. I put 4 screws in each of those to make sure everything stays put. And now we should be ready to solder that whole assembly together. So I will in fact do that. Here's some flux, and everything's been pickled, of course. And get everything screwed together. Once again, these pieces are close together and everything's well secured, so it was pretty straightforward to solder this entire assembly, all 8 joints or whatever this is, all at once. You got to be a little careful getting greedy with that. You know, Kozo always recommends doing one component at a time and cleaning and fluxing between each set of joints before doing the next, and I think in general that is the smarter move, but once you gain a little confidence, you can kind of learn a few areas where you can cheat, and this was one of those areas. And that went really well. Those joints all look great. I gotta say, this thing got really strong with those side pieces on there. I mean, honestly, you could stand on it. I wouldn't, but I think you could. It's very sturdy. So now it's safe to cut the saddle to final dimension all the way around. It's still over dimension on every side. This was, in principle, a straightforward bit of side milling. However, this is copper, and with copper, nothing's ever straightforward. It'll bite you if you're not paying attention. But this actually went fine. I had no issues. A full height side mill on fairly thin copper that also has been annealed. It's going to be extra grabby because of that. Is a little bit of a dangerous game, but I'm pleased to say that went just fine. I was also able to mill the edges of the scallops flush in this position because once the saddle has been trimmed back, it's further in than the edges of the sides are, if that makes sense. So I was able to stick the end mill down and side mill those to be flush while I'm here. And the remainder of the edges I hand filed flush. This is always quite satisfying to do. I like this technique of cutting things, soldering them together oversize, and then filing them flush to get perfect edges. It's very satisfying. I'm using a safe edge file there up against the underside of the saddle so that the edge of the file won't chew up the curved copper area. If you don't have safe edge files, you should make some. All of my safe edge files were made in the shop simply by grinding the teeth off one side of each file. With those screw heads filed off, that is looking pretty decent, I have to say. So it's test fit time once again. I did a lot of test fitting as I went along on this whole assembly, and it's a good thing because I kept finding little quirks here and there, little things I didn't understand or new little errors between assemblies, but we're definitely getting close now. So the boiler sits down on there pretty good, but the fit is good, but it still wasn't quite as good as I felt like it should be, and so I took it over to the other bench where I can inspect it easier, and I did a whole lot of poking around, fiddling and fettling and measuring and checking with level, and I decided that the real core issue here is that the boiler wasn't sitting quite right. It wasn't perfectly centered in the frame between the footboards, and it wasn't sitting as straight as I thought it was. And it took a while to figure out why. Why couldn't I get it to sit straight or sit in one place consistently? And the issue turned out to actually be a solder blob on the foundation ring. There was a little blob on there that it was kind of rocking on, and all it took was a little bit of a milling cut on the top edge of this grate rail to make clearance for it, and that solved basically all of my boiler fitting problems. Now it sits perfectly on all the frame rails, and the edges of the mud ring are sticking down into the fire, into the grate area the way they're supposed to. It looks much, much better. Now I can mark the final height for the front and rear plates that are still over length because I know everything's in the correct position. And if you're wondering why I opted to mill a clearance for that solder blob on the foundation ring, it's because I wasn't going anywhere near that joint with a file. If you know what I went through to get that boiler to pass pressure tests, I was not going to risk damaging those joints. So it was much safer to just clearance the area. So I made the bottom plate over on the shaper, and that got drilled and tapped and yada yada, fit on the bottom, and then also got a hole drilled here to clear the steam oil injector that sticks down through the bottom of this assembly, because of course we have to be able to plumb the steam oil into it. Then from this position, I center drilled the bolt pattern, which again is plan view projected. Then I tilt it over to be square to the surface, re-center drill it with a larger center drill once I know the location, and drill that through for clearance holes. Then I reassemble everything and transfer those holes to the smoke box with everything sitting in its final position, and drill and tap the holes on the smoke box. This was a lot of assembly and disassembly and transferring and careful checking and so on, but now I can screw the saddle to the bottom of the smoke box, and if I did my job right, this whole thing now should just drop right into the chassis. There's a lot of variables that all have to be correct for this to work, but I'm pleased to say, spoiler alert, for the next 7 seconds that this is going to drop right in there. Look at that. That is perfect. You can tell now, too, that the boiler is sitting more solidly, like there's no rock or weirdness in it. It was always a little weird how it sat in the frame before because of that solder blob interference, and now it's sitting really solid, and it goes down in the same place every time, which it kind of didn't feel like it was doing that before. But now I can get this bottom plate installed. These screws were a lot of fun to get in, as you might imagine. The rear two are almost completely blocked by that cross linkage for the drain valves, which makes me think again that this bottom plate might be a late design change, but it's solid on there now. It's not going anywhere. I want to backtrack 1 second here because I don't think I ever explained this very well. You can see that the box of the saddle wraps around the steam manifold, and there's space all the way around it and also above it. And that whole void area gets filled with ceramic wool at the end as insulation. So the job of the saddle is, I guess, to sort of support the front of the boiler. It clamps it from being lifted against, but mainly its job appears to be to insulate the steam manifold and hold the heat in as it comes down out of the boiler, and the steam is going to heat everything up, and we want to contain that heat. As I've said before, steam is external combustion, and so heat is precious. You have to do everything you can to keep it in the system as it travels from boiler to cylinders. In internal combustion, which is what most people are more familiar with, heat is the enemy. You're doing everything you can to get rid of it. Not so here. There you go, one boiler saddle. That was an adventure in test fitting and fettling and filing and making things work, but I think I did in fact make it work in the end, and I'm pretty happy with the result. I don't think I could have done much better with that. And I've learned for future locomotives how important all of the dimensions on the boiler are, because so much depends on the boiler being perfect, which is a tall order, frankly. Again, the boiler is a sheet metal and soldered structure, and I guess Kozo expects you to be a better Boilermaker than I am, because some of his tolerances on related components are pretty tight. But I made it work. Thank you so much for watching. Thanks to my patrons for making all of this happen, and I'll see you next time.